Welcome back. This is our last section for chapter 6, 6.7, type 3 of our electrolytic cells. So this one is electrolysis of aqueous salts with reactive electrodes. So the only difference between these ones and the type 2 is just we have our electrodes that are that could potentially react if the conditions are right. So let's start off with our cathode. So cathode metal not reduced. Metals cannot gain electrons and become an anion. Cathode metal not oxidized, right? Oxidation does not happen at the cathode. Remember, Leo is a jerk. Uh, Losing reduction is oxidation at the anode, and at the cathode we have a reduction. The cathode metal never reacts. So the cathode is only a service for the reduction of the cation or of water to happen. So basically, everything is the same as type 2 at the cathode. So the highest on the left is our cathode. So just like in our type 2, all we're doing, we look at the cation, look at water. Is it above the arrow? Then it's going to react. If it's below the arrow, then we're going to have water reacting. All right, so just the same. So that's good news. All right, so let's look at the anode. Three possibilities at the anode. So we have the anion of the solution is oxidized. We could have water is oxidized, or the anode metal is oxidized. So basically, just like in our type 2, we want to go for the lowest one on the right. All right, so the lowest one on the right is going to be oxidized at the anode. All right, so let's look at a problem. So we have a nickel and iron electrode, and in the solution we have Al2SO4, and these are aqueous. All right, so we want to figure out what is going on where. So look at your table. So this is how I do it. I'm gonna just do everything down like I would have my table. So hopefully you have your table out. If you don't, pause it, go grab your table. So I want to disassociate the salt into ions. All right, so I got our SO4 2 minus, Al3 plus. I have my iron electrode and my nickel electrode. All right, so I hooked my iron up to the negative terminal. That is my cathode. I hooked my nickel up to my my positive terminal, and it is going to be my anode. All right, so what I have to do, I have to decide my anion, water, or my nickel at the anode. All right, so first I'm just going to look on my table. All right, so what's the lowest? All right, so there's my nickel. All right, I'll put above water, and at the top would be my SO4. Should be SO4 2 minus. All right, so now let's look at the other side. All right, so my cation is Al3 plus and water. So there's water and Al3 plus. So this is exactly the order that I would see them on my table. All right, so basically we look at it. So that means my nickel is going to react at my anode, and the water is going to react at my cathode. All right, so now I have all my stuff. I know what's going to be reacting. Remember, lowest on the right, highest on the left, right? So the lowest potential between them, that is the reaction that's going to happen. All right, so let's go to the page in front of you so we can go and fill out all this stuff. All right, so my anode, right, is my anode. My anode is my nickel. That is because it's on my positive terminal. Cathode, right, is my iron. It's on the negative terminal. Anode half reaction. So we already talked about it. So nickel was lowest on the right. So we're gonna have the nickel Ni going to Ni2 plus and 2 electrons. All right. The opposite as I see it on the table, and it's negative 0.26 on my table. So I'm going to flip the sign, positive 0.26 for my anode half reaction. All right, cathode half reaction, we decided it was the water, right? So the water is going to happen. So that's highest on the left. So I just write it exactly how I see it on my table, and I put the potential exactly as I see it on my table. All right, so overall reaction, electrons are already balanced. So reactants stay on the reactant side, products go on the product side. So my overall reaction is going to be this. And my potential, add them both up. So that's going to be negative 0.15. All right, so not a lot to get this reaction going. I need 0.15 volts to make it happen. All right, so product at the anode, right? So at my anode, I'm making Ni2 plus, right? So that's my product of my anode, product of my cathode, and basic hydrogen gas. That's what I'm going to notice. I'm going to notice the bubbling of hydrogen gas around my cathode, right? And minimum voltage necessary, 0.15 volts. and a precipitate that while the cell is reacting. So this is an interesting question. So with this one here, I would have to go back to my knowledge from solubility, and I would have to find out what is going to form the precipitate. All right, so I'm going to be making OH minus there, and I have Ni2 plus. So and I see my Ni and OH minus has low solubility, so I'm going to be making NiOH2, our nickel hydroxide, out there. So you might notice a little precipitate being produced while while the cell is reacting. All right, so just to recap this, so it's always going to be highest on the left, lowest on the right, right? Cathode is exactly the same as our type 2. Anode, all we have to do is now consider the electrode, and in this one, the electrode was the one indeed reacting. All right, so those are our type 3s. Applications of type 3 is electroplating. So electroplating, basically what you're going to do is when you're electroplating something, you're covering it with a metal. We do this with a lot of things, like all these shiny things all over the place, like wrenches or even like faucets, door handles. These are all electroplated to have a nice shiny coated surface on them. So lots and lots of things are electroplated, like especially like jewelry or things that get a lot of daily use. So basically, a metal is reduced or plated on top of an object connected to the cathode, right? So we just connect it to the cathode, make it the surface for the reaction, uh, connect it to the negative terminal, make it the surface for the reaction, and then we can plate it with whatever we want. All right, so let's talk about the process for this. So the cathode is made of the material which will receive the metal plating. So we make the cathode simply by connecting it to the negative terminal. The electroplating solution contains the ion of the metal which we wish to be plated on the cathode, right? So if we wanted to plate this key, this looks like we're plating this key with copper, so we put a copper solution in there. If we want to plate it with silver, we put a silver solution in there. If we want to plate it with gold, we do the same, gold solution. The anode is made of the same material used for plating the object. All right, so again, so it looks like this is plating it with copper, so they put like a copper strip right there, and that's used to plate. So it's pretty straightforward. You have the solution and the anode are all made of are all containing the ion for the metal that you wish to be plated. All right. So let's do another example. So we want to coat this spoon. All right. So maybe it's like an iron spoon or something like that, and we want to coat it with silver. All right. So basically, we're going to hook it up to the negative terminal, right? We're gonna putting on the negative terminal is going to force electrons into it. So the electrons are always going to be going from the anode to the cathode, just like before. So that makes this spoon the cathode. All right. So we want to plate it, so we hook it up to the cathode. Electrons are going to be flowing down towards it. We're going to try to make it real negative. We make it negative, then these silver ions, they're going to be attracted to it, and they're going to plate on the surface of the spoon and get that nice shiny silver spoon. All right, so that means this over here. So we're going to have a silver bar here. So this is going to be our anode. The anode's always made of the metal that we want to plate, right? Because at the anode, right, we have our LiOA, we have our oxidation happening. So it's going from silver metal to silver ions. So basically, for each a silver ion that's reduced at the cathode, another silver ion is being produced by the anode. So it's continuously replenishing the solution. Another thing to note is that our electrolyte will have the ion in the solution. So in here we have our silver nitrate, and this is providing silver ions to start the reaction, right? So we didn't have to run it for a while, wait for the oxidation to happen, and then the reduction. We already have silver ions floating around the solution, and they can get plated right onto the cathode right away. At the cathode, we have our gaining of electrons supplied by the power source, and then it's all negative, and basically the silver is reduced and it sticks to the spoon, right? So and plates a spoon, giving that nice surface, that nice surface covering of the silver on top of it. All right. So let's do another one. So this might be a question that you may have in your homework or in other tests or assignments. So we want to design a cell to electroplate an iron nail with nickel metal. So include the design, the ions present in the solution, the direction of ion flow, and the substance used for the anode and the cathode, and the direction of electron flow when the cell is connected to a DC power source. All right, so we have our nail in here. Here is our anode, right? So we can see that it's connected to the battery, right? So battery or power source, whatever, and we have the negative terminal. So then, and it's connected to the negative terminal of the battery, and so we're forcing electrons down in there. So electrons are going to be flowing down to the nail, and they're also going to be flowing away from our anode, right? So we got that done. So that's my flow of electrons there. All right. So my my nail, right? Since I attach it to the negative terminal, it's going to be the cathode, right? So we're going to have the reduction going on the cathode. So my nickel is going to be plated on top of my cathode. At my anode, right? We're going to have the oxidation going on here. And so we're going to be losing electrons here. Electrons are going to be traveling, right, pulled away from there. So it's going to be going from a solid nickel, right? It's a nickel bar here, going to Ni2 plus to 2 electrons, right? Our electrolyte, it's going to have NiNO3 too, right? So we're going to have Ni2 plus ions floating around in solution. All right, so it's so anytime you want to plate something with something else, the metal that you want to be plating, it's pretty much all over the place, right? So you have a nickel anode, the cathode is an iron nail, and you have nickel being plated onto the cathode, and then you have an electrolyte with a nickel ion in there, right? So always make your electrolyte the spectator. So if it's I did AgNO3. Use NO3 all the time when you're making your electrolyte. It just makes things much more simpler. All right, so with these ones, not a lot, right? A lot of repetitiveness on this one, but that's just what you're doing, right? You're plating it over and over again with nickel ions onto the iron nail, right? So you want to cover it with nickel. So you're getting the nickel from all these different sources. You're getting the nickel from the anode, the oxidation of the anode. You're getting the nickel from the electrolyte. It's in the solution, and then it gets plated onto there. All right, so this is how you would do this this type of question. So you're going to run into these types of questions in your homework and maybe on quizzes and tests as well. All right, so there we go. Work from the booklet, extra work, page 243, 71 to 72. And that's that.